Welcome to Lesson 16, Wi-Fi Standards, where we turn router spec sheets into something you can actually act on. In just 25 years, Wi-Fi jumped from 11 megabits per second to 30 gigabits with Wi-Fi 7, and today's offices run a mix of 5 generations across 3 bands, 2.4, 5, and 6 gigahertz. Over the next 4 pieces, we'll cover generations, bands, speed factors, and security. So, by the end, a Wi-Fi slow ticket stops being a mystery and starts being a checklist. Let's start with generations. The IEE publishes the technical standard 802.11, born in 1997, and every new version just tacks on a letter. A, B, G, N, AC, X, B. Since those names are awful to remember, the Wi-Fi Alliance rebranded them as Wi-Fi 4, 5, 6, and 7. So 802.11 is Wi-Fi 6 and 802.11be is Wi-Fi 7. 2 things to lock in. Newer routers stay backward compatible, so old phones still connect. But the speed any device actually gets is the minimum of the router's generation and the client's. Upgrading only the router won't make a Wi-Fi 4 laptop any faster. Now, generation is only half the story. The other half is which radio band you're actually using. There are 3. 2.4 gigahertz, the old workhorse from 1997. Long range, walks through walls, but completely jammed because every microwave, baby monitor, and IoT gadget lives there. Then 5 gigahertz. The modern sweet spot, faster, less crowded, decent through 1 or 2 walls. And 6 gigahertz, brand new since 2021, blazing fast and basically empty, but short range, and only Wi-Fi 6E or 7 devices can even see it. No band wins. Pick by use case. Now let's stretch those bands across time. In just 15 years, we went from Wi-Fi 4 at 600 megabits to Wi-Fi 7 at 46 gigabits. That's 75 times faster, on the same SSID your laptop already remembers. Notice the pattern. Each generation either added a band or learned to use the existing ones smarter. In most 2026 offices, you'll be supporting Wi-Fi 6 as the standard, with Wi-Fi 7 rolling out and Wi-Fi 4 and 5 still hanging on in older buildings. So where does that speed actually come from? 4 levers, and they multiply each other. First, channel width. Wider pipes from 20 up to 320 megahertz carry more data, but each spectrum in crowded areas. Second, MIMO. Multiple antennas on both sides creating parallel streams, so a 4x4 setup gives you 4 times the throughput. Third, QM, denser modulation, packing more bits into every radio symbol, roughly 25% more speed per generation. And fourth, OFDMA, which lets Wi-Fi 6 and up serve dozens of devices in parallel instead of one at a time. Multiply all 4 and you get the headline gigabits. Speed is only half the story though. Without encryption, Wi-Fi is just radio waves anyone in range can read. So if you spot WEP or plain WPA on a router, treat it as wide open and replace it immediately. Both were cracked years ago. WPA2 from 2004 is what you'll see on roughly 95% of networks today. Solid AES encryption with a personal flavor for homes and an enterprise flavor using Radius for offices. WPA3 from 2018 is the upgrade path. It swaps the old pre-shared key handshake for SAE, which resists offline password guessing and adds forward secrecy. And on hotel or cafe Wi-Fi, if there's no password, assume someone's sniffing and lean on HTTPS or a VPN. Now let's put it all together with 4 real tickets. Ticket 1, fast in the office, slow at the desk. That's classic 5 GHz range loss, through walls. Move closer, drop to 2.4, or add an access point. Ticket 2, laptop connects, IoT camera won't. Your camera is 2.4 GHz only. So split off a dedicated 2.4 SSID. Ticket 3, packed conference grinding to a halt. Too many clients sharing airtime, which is exactly what Wi-Fi 6 OFDMA was built to fix. And ticket 4, New IoT refusing WPA3, drop those legacy devices onto a WPA2 only SSID. Same pattern every time. Match the band, the generation, and the security to the weakest client on the network. Before we wrap up, here's your cheat sheet: 12 terms that show up on every spec sheet, ticket, and access point data sheet you'll touch. You already know most of them. 802.11 is the standards family. SSID is the network name. WPA2 and WPA3 are your security generations. Band is the frequency range, and channel is a slice of that band. The newer ones, MIMO, MUMAMO, OFDMA, QAM, are all about squeezing more clients and more bits through the air. And roaming and mesh, that's just how multiple access points share one SSID so you don't drop as you walk around. Memorize these and you're speaking junior wireless fluently. Now, with the vocabulary fresh, let's clear up 5 myths that cause real diagnostic mistakes. Full bars don't mean fast internet. That's signal strength to the access point, not your ISP speed. 5 GHz isn't always better. Through walls or at distance, 2.4 GHz wins. Wi-Fi 6 routers happily serve older clients, just at older speeds. Guest networks only protect you if AP isolation is actually turned on. Check it. And WPA2 still works, but it's been cracked since 2017, so plan your move to WPA3. Spot these on a ticket, and you'll fix problems others chase in circles. And that's Wi-Fi locked in. 5 generations, 3 bands, the 4 levers that drive speed, and the jump from WPA2 to WPA3. You can now read a router spec, pick the right band for the job, and triage a Wi-Fi slowed ticket with real confidence. Next up is the Stage 2 capstone. We'll trace a single packet from your laptop all the way to google.com, tying 9 networking lessons into one clear picture. Then Stage 3, hardware and peripherals, begins. See you in Lesson 17.